Hello, we're going to continue talking about the remainder theorem, and we're going to look at an example where our divisor is not just a simple binomial. This time it has a 2 in front, but it really doesn't make any difference. When I'm setting up my division statement and I'm about ready to write in my dividend here, I do notice that it's missing a term. It's missing an x squared term. But that's okay. We need to fill that space with what we call a placeholder. And so when I am writing that dividend statement, I actually add a 0x squared. This is very important. If we don't do this step, the quotient will not be the correct answer. Again, make sure that each of your exponents is descending by 1, and if you're missing one, you need to add it in. If you're missing another one, you need to add that in as well. Now we can continue the way we approach the other two questions. So over on the side, or maybe we've got this part down so we can do it mentally. I know that I need to multiply 2x by 2x squared in order to get my 4x cubed. That 2x squared goes on top, forming part of our quotient, and now the rest is fairly routine. We're subtracting. I'm not going to use brackets this time. I'm just going to talk it out. 4x cubed minus positive 4x cubed is 0. 0x squared minus a positive 2x squared is negative 2x squared. Bringing down the next term, I repeat. And again, I'm going to try and do this mentally so I don't have to keep writing all of this scrap work over on the right-hand side. 2x times what equals negative 2x squared? That's going to be negative x. Negative 2x squared, negative x times 1 is negative x. And once again, I'm going to subtract. First terms disappear. Negative 9, subtract a negative x is really positive x, so I am ending with negative 8x. Bringing down my final term, and I can see that I need to multiply 2x by negative 4 to achieve my negative x, and negative 4 times positive 1 is negative 4. Subtracting one last time, first terms disappear, that's good. Negative 12, subtract a negative 4 is negative 12 plus 4, which is negative 8. So 2x plus 1 divides into 4x cubed minus 9x minus 12, 2x squared minus x minus 4 times, with a remainder of negative 8. Let's look at a third example, where this time all they want us to do is use the remainder theorem to determine the remainder. They don't actually ask us to use long division, they just want to know what the remainder is. So if we flip back and we look at the examples we've done in the past, when I divided this dividend by this divisor, the remainder was negative 5. That's all I want in this question. In order to do that, we don't have to work through the whole steps of long division. What we can do is we can recognize that when I substitute in negative 1 into, that should be a 1. Let's just undo that. When I substitute in negative 1, wherever there's an x, this will generate my remainder, if that's all they ask. So by substituting in whatever x equals, negative 1, this is a very quick and efficient way of just finding the remainder. It doesn't help me find the quotient, but it does help me find the remainder. Plus 1, plus 3, subtract 6. And so when I solve this, I can add them up very quickly. Negative 2 plus 1 is negative 1. 3, that should be negative 4. So the remainder, when I divide x plus 1 into 2x cubed plus x squared minus 3x minus 6, is going to be negative 4. So just be careful what they're asking. The final example we're going to take a look at is, this time they've given me a partial polynomial with two variables, x's and k's. I am told that when I do divide x minus 2 into this polynomial, the remainder is 8. So the equation looks something like this. So if I'm able to replace the x here and just temporarily write p at 2, so that came from up here, is equal to 3, and replace all my x's with the 2. Oops, that should be a 4, and that should be a 4. Minus 7 and a 2 minus 10. Now, I still am left with this p at 2 over here, but we were told that p at 2 is equal to a remainder of 8. So I can now replace p at 2 with 8 and expand all of this out. So this becomes 3 multiplied by 16 plus 8k minus 14 minus 10. I can now start collecting terms. 8 is equal to 48 minus 24 plus 8k. 8 is equal to 24 plus 8k. And if I bring it to the other side, I have negative 16 is equal to 8k, and k is equal to negative 2. And there we have the answer. So this completes all the examples. The key concepts are very important. Make sure you read through those. You may want to pause and read through, or flip to your textbook. And then finally, the homework assignment is here. This video, as well as all the rest, are searchable under the YouTube channel Mr. Sampson Halton Math, and that should get you there. Thank you for watching.